So in today's session, we'll discuss how we can create a parametric family and also how we can customize any given family. After this, we will see what massing is and how we can do massing in Revit and also how we can create a side component in Revit. Let me open Revit. So we know that just place any family just like that, or say furniture. So this desk, for example, say, we know that we can place something like this off the shelf. And we know if something is not there, we know how to download it or how to load into the project by going to insert, load family, and wherever it is, we can load it from here. But what if the shape which we are looking for or the object which we are looking for is not present by default and we want to create? As I've said earlier, we can create with three methods. One is we can create it with the model in place, which is, as we discussed this thing earlier that day, we can create in model in place whenever the case is like that particular object or that particular shape or that particular element is going to be used only in that instance or only in that project. But we are going to create families whenever we think we require them more than one project in more than one project. See, for example, this furniture. If we know that we have the requirement for this furniture and we are going to use this particular type of furniture for more than one project, then it is better to create this as a family. So the third method is insight, which is not for objects, it's only for structures which are complex in shape. Now let's see how we can create a particular type of family. So whatever we have done until now is only in this interface, right? But if you want to create a family, you have to create it new. That can be accessed via file. You can just go to new. Until now, we have selected project, right? For creation of project. For creation of family, you have to select family because we are creating new family. Here, as we've selected template for our project file, right? You know, the default metric or default imperial. Likewise, you have to select the template for our family also. What you are going to create, which enables certain default settings into that. Like say, for example, if you are creating a wall, a door, this door has a wall pre-installed in it so that if wall sizes changes, the door size also changes accordingly. Likewise, for example, let me just create a generic template or a generic family as of now, just for your understanding purpose, so that you can understand how this parametric family works. I'll just, since we are in metric template, it's showing only the metric uh, templates for the family. If you are taking the imperial one, it will show all the imperial family templates. Right now, I'm in metrics, so I'll just take a generic model, metric generic model. So you can see as soon as I hit the family template, the whole environment is going to be changed. This we have seen somewhere where as soon as I go to any level, as soon as I to go to floor plan and I hit model in place and select anything, I will be in this environment. But here what happens is I will be there in the project itself, but whatever I create, I'll be placing on that project. Say, for example, I'm in the level 1 only, but whatever I create, it's going to be reflected over here. But if I take this template, family template, I will be completely out of any model. There is no model, but I can create with these tools in this separate environment, whatever I'm going to create. Now, my aim is what I want to create is I want to create a box. That box, if I give inputs that has to expand or contrast, change its shape. Like here, if I change the dimensions over here, the depth, say 762 is there, right? If I make it 1000, it's going to change its shape, right? And if I make it say width 1500, if I make it 2000, it's going to change, right? This is going to change because it's parametric. So you can see in 3D as well. Say it's 2000, right? Let me change it to 1000. You can see it's changed its shape, right? Why it's changing? It's changing because it's parametric. So now let me create a parametric object, just a cube for your reference. For that, I've taken metric generic template. OK, in order to create a parametric object, you have certain default functionalities or certain default logics. So let us explore that. First is you will be greeted with these planes. These are nothing but the reference planes. One is in X direction, the other one is Y direction. Whatever the template we are going to take, you will be having certain reference planes, because whatever the object you are going to create, it should have a basic reference plane. That is why it is present by default. But most of the cases, only two are not sufficient. So the first thing we are going to do is we are going to add certain reference planes additional. I'll just go to in the datum section. We have reference plane. I'll just select reference plane. I'll just add two more in each direction, X and Y. The logic for this is we will know in a minute. OK, I have created. You don't have to worry about the distance between this and this and this and this. It may not be equal. We will adjust that later. So immediately after creating these reference planes, what we are going to do is we are going to annotate. In the annotate, just take the aligned dimension. 1, 2, 3, and click outwards. Same 1, 2, 3, click outwards. Now what happens is if you're doing like this, just click anywhere in this type of settings. You'll have something called EQ, which means if you're selecting between 3 reference lines and these 3 reference lines are not of equidistance, which means the distance between these two is not equal to these two, you have this mark. And if I click this mark, it will adjust itself. The center will not move, either this side or this side will move, so that the distance is equidistance. And how much the distance currently doesn't matter, because we are going to adjust it later. The same way, this distance, this point and this point, this point and this point is not equal to this point and this point. So we are having this EQ check mark. So if I click on this mark, you will have your equidistance, which means the distance between this point and this point is equal to distance between this point and this point. Now we have 4 equidistances. After that, again, I'll go to annotate, just check align, give the final dimension. First click, second click, and just leave it outside. So we have 2 dimensions. Now, my aim is whenever I'm going to place something over here, all right, that has to adjust, just make it outside so it will be clear for us. So my aim is now whenever I'm going to draw something over here, I will snap or I will link that edge with this dimension and this edge with this dimension, so that if I change this dimension, that edge also should change. So why did we make equidistance? We did make equidistance because, for example, the dimension currently is 3600. If I make 3800, all right, it should be distributed equally. The change in length should be equally distributed, which means the change in length is 200. 3600 plus 200 is 3800. So that 200 should be split equally between these two sides, which means this will increase 100, this will increase 100. Likewise, here also, if I make 3200, 100, if I change, this point will be increased 100 in this direction. This point will be increased 100 in this direction. So I'm trying to split. After this, what I'm going to do is I'm going to label this. So this will be my length or width. This will be my length. So just rename that. How do we rename that? Click on that dimension. You have something called label over here. Click on that label with this create parameter. We have family parameter here. I'm just going to name it as length. Now we have two types of parameters over here, type and instance. Type parameter is something that, as we have seen in that particular furniture, I'm going to edit type and change it over there. For that, we are going to use type parameter. Instance parameter, mostly for architectural, we don't have this use. Instance parameter is something we will discuss later. Okay, let's mark it length, and length is nothing but a dimension, right? We have multiple parameters over here. Among these parameters, I'm going to check dimension for the length, because length is anyway dimension. Here also click on this check label. Now I'm going to rename it as width. This is also type parameter, and I'm going to group it as a dimension. So we have two parameters. One is width, the other one is length. Now, after doing this, I'll just go to create again. Now let me take an extrusion. Take a rectangle, something like this. After doing this, so we have these parameters, and I want this extrusion to happen in parallel with these parameters. So what I do is I just drag it to a place where it is in sync with our reference plane. As soon as I go, you can see there is a lock option. Just lock it. Likewise, you have to do it for 4 directions. So after having your 4 directions, just finish it off. Now let's go to 3D and see we have our extrusion. That is on X and Y direction. The length is we know. We can change the length by giving the input over here. Let's say if you want your length to change to 4000, just hit 4000 over here. It's going to change, and it's going to change here also, because it's going to change simultaneously. After having your length and width, let's go to the front view. Here, this is a reference plane. In the reference plane, we have a reference level. If you want to see the object from front view, just go for front. So we have our front view. Now, if you observe over here, there is no height dimension over here. For that, you have to create another reference plane like this. Now what I do, I'll just go to annotate, align this particular, just check this reference plane. I just hide this first temporarily so that I can just drag this outside like this. So that's it's visible for me. Like this, it's visible for me. Now I'll unhide this. Now I have this reference plane that is present by default. What I'm going to do, I've created a reference plane already. I'll go to annotate, I'll take align, select these dimensions, click outside. Have to be equidistant here because there is no way to expand parallelly. Whatever the height I'm going to give, it is going to take that height. So I'll just select this parameter. In the label, I'm going to name it as height. This is also a dimension. After that, just expand it and lock it. Now we have our length, width, and height. That is what a block is all about. After doing everything, if you want to give a material for this, select this block. You have something called material. Here, if I click on this material, whatever the material you want to give, you can give. Either it is glass or wood or whatever the material. After giving that, you can make it look realistic as well. So we have a basic block with length, width, and breadth dimensions. Now all you have to do is you have to save it somewhere. Save as family. So Revit family, Revit format is .rbt, right? But if you're saving a family, its type is .rfa. Save it somewhere. I'll name it as block. After saving that, you can directly load into the project. it will load it into whatever the existing project we have. Currently, this is what our existing project, right? It will load in the project. Now we can say I can place this. So why this is called parametric family? You can just delete it also. If you want to load it again, go to component, place a component. So here, whatever the block we have created recently will be loaded. So if I take it, make it realistic, it will look realistic. Let's go to 3D and check our block. So this is what our block is. Now, why do we call it as a parametric family? We do call it as a parametric family because we can edit it. Let's see how we can edit this. Click it. As soon as I go to edit type, we have three type of dimensions which we can edit: length, width, and height. Say height, if I want to change to 2000, say, hit 2000, apply, it's going to change its height. You can see it's changed. Say width, if you want to change, click edit type, and the width from 3600 to 2000, it's going to change. Even length also, if you want to change 2000, maybe change. So whatever the input we are giving, it's going to change as per the input. That is why it is called as a parametric object. And how where did we create? We did create this using a parametric template. For suppose you want to edit this family, you can just select it, double click it. That's it. You will be in the editing environment again. Not only this, whatever the family you feel as a need to edit, just double click on that family. You will be in that family environment. If you want to change something for that family, you can just change it. So here, again, if you want to add any value or just give any input, additional input for this given family, you don't have to open that in the family environment. You have to just double click that particular family. You will be in that family environment where you can edit or give additional information for this family. Here, so this is how, this is what the logic is. This is what the basic block can be formed. So as you progress over here, there are multiple complications. You can add multiple datas and you can add constraints. So constraint is, say, for example, this is width, right? You can constrain this width, which means, for example, if you want to change this width as per the length, which means, say, length is 4000, width is 3600. If length is 4000, if you want your width to be half of your length, all right, which means width will be 2000, right? If length is 4000, if you want your width to be half of your length, it will be 2000. You can program it. So you don't have to mention width. You can just mention length, and as per the length, width will be adjusted. That is called constraints. So you can add multiple constraints for any given label as well. So this is a width label, right? Click on this width or click on this width label and you can add constraints as well. So just a minute. So this is what a normal label is. If you want to create a label with constraint, again you have to create once again, or select any label, the given label. So here we have default labels. You can just go to not VG, one second. So there is a change in Revit 2023 version actually. In 2022 version, there was like uh, this was done in another method. So just bear with me. I'm just trying to explore. Give me a second. So I'll just update it later because I just don't want to waste the time. But you got the idea, right? How to create a basic block. Now let's try one more block so that you'll get an idea of creating some other blocks. Let's say you want to create a typical or a door type which is not there in the catalog. So I want to create that door type. Again, I'll just edit this first. This one also. I want to create a new type of a door. I'll just go to File. I'll just go to New Family. So here I want to create a door. For that, I'll just take a metric door template. Open. So why we are taking template? We are taking template. I'll just go to 3D of this particular version, and I'll just make it 1:1 because that name is causing hindrance. So here you can see to make it shaded, realistic. You can see if I take this particular type of template, what is it's going to help me with the wall. Why? Because the door is a constrained element. We cannot place a door without a wall. So the wall is present by default. Whatever we are going to place here with this particular wall, whenever the wall type is going to change, say this is a 300 mm wall, and if you going to change this particular wall type to 200 mm wall, it's going to automatically adjust. That is why we are choosing the wall template, the door template for creating a new door. Now I'll just go to reference plane. You can see every constraint here, it's already being loaded. The weight, equidistance, and all whatever we've discussed. The frame projection as well. Now, if something is loaded like this, it saves us the time. You can see these are all the constraints that have already been loaded in the project, so that we don't have to waste our time creating all these things. Now I just go to extrusion. I will take any command. So for example, say you want to fit your door like this in the external edge or internal edge. All you can do is just grab it and lock it. Grab it and lock it. Anyway, this side you are not going to expand. That is why. So if you're going to change the width over here, these dimensions can be applied. Likewise, I'll just go to exterior elevation, and once I finish it off, you can see I can drag it until here. As soon as I drag it, I can just finish it off over here so that I have a solid like this. So as soon as I change its height or size or shape, it's going to reflect. Now the only thing that is remaining is I have to give a material, and also I have to give the door handles. That also you can create. Select this particular door, go to materials, you have some material catalogs. There is no wood. Just you can give it like that. I just go to exterior wall and I want to create a door handle. Let's say I am going to open door in this direction. I can go to create again. Just go to extrusion, something over here, a doorknob like this. Finish it off first. Then you can just go to left or right. So this is what your door handle is. So if you think it's only in one direction, just sorry, I've dragged in the opposite direction. It has to be here. So anyway, if you think it's going to be in one direction, just check it whether you're drawing right or not. You can see I have my doorknob in this direction. So that's okay for me now. I have to create a shape which I can grab. Just go to create, extrusion, take this line, something like this. Satisfied with this, I will copy this. So I want to finish it off because I want to execute this. So I'll just finish it off in both the directions. So after that, finish it up. You have your spline. Now let's go to left because I want to see this. Now I can extend from here to here. so that I have my doorknob like this. You can see you have formed a doorknob. The same you can do it to opposite direction as well, but I have to mirror it or I have to copy it. Instead of that, let's do it one more time. So here, this direction we have to have that. Let's go to create extrusion somewhere in the middle like this. Like this. Finish it off. Left. So here it's there, but it has to be only until this point. Again, I can go to interior. So I have the circle. Now what I have to do is I have to just create a handle. Just go to extrusion again and just take this spline again. Something like this. Just created a random figure. Just don't consider shape. I just wanted to make you understand. So interior is fine. I'll just, this is what, say it has to come in this direction. I'll just drag it until here. This I'll extend here. So we have a doorknob, internal window. If you want to customize or give it a, say this is an operation theater. If you want to cut it, you can do that also. I can just select this for edit extrusion. 3D view, if you want to cut it in 3D view also, it's possible. It's okay. Something like this. Okay, it's not possible. In these cases, if you want to cut like that, what you can do is you can just go to elevation, create. So you have to go for void form, void extrusion, select the tab, and for example, say this is where I want to give it a cut. Just make it in 3D. You have the cut. All right, like this. Here you can just create a, what you call, if you want to create a glass panel, that is also possible. Create extrusion. I'll just pick this plane and like this, finish it off. I'll just go to any right or left side so that I can see like this 3D. So this particular part, now I can select the material as glass. So that I can see. So imagine this room is for this particular door is for operation theater of such. So we have handles, door type, and also an opening as well. So if you're done with this, file, save as, family, desktop, and save it as door. RFA is okay, door, save. Then after saving, you have to load it in the project. So whatever the project is open, it will be loaded in that particular project. As soon as you can see, as soon as I open this project, whatever I have done, it's going to be first thing that has been reflected in my project. So I've placed that. Let's go to 3D and check. Now you can see whatever we have done, it's been reflecting over here. Likewise, you can create any customized objects or customized doors, windows, furniture as per your requirement. This trim can also be changed or modified. This glass thicknesses, this door handles, knobs, all the materials, the texture, pattern, you can customize as per your requirement. You can even if you can import your AutoCAD drawing or any detailed image if you have. You can even insert that image also in this say format or family so that it looks exactly as per your drawing standard. The same for many elements. So whatever the elements we have here, we can create the families for all those elements. So you can see we have balusters, columns, doors, ducts, electrical equipments, furniture, generic models, lighting fixtures, mechanical equipments, plumbing fixtures, profiles. The profiles, these profiles, if you remember, we have discussed about the profiles in wall patterns, right? And also the baluster patterns. So you have to create these profiles over here. These profiles, once you create, you can just load it in your balusters or in your wall sweeps and wall reveals and all those cases. And the rebars, structural components, many elements can be made over here. All right. I think you're clear about this families, right? You have any doubts? One thing I forgot. So in the family, if I go to family and if I take any element, you have this element named in type or instance, right? Now, let me just select any parameter. This parameter is there, right? So this width parameter or you cannot select any parameter once it's created. It's not possible to re-edit these parameters again. As you can see here, you can select any parameter, but once the parameter is selected, it's not possible to edit that again. So you have to make sure that whatever the parameter we are going to create, it stays as per its description. But the difference between instance and type is instance parameter will only reflect here. So here, so I'll just show it with, say, window. If I place window over here, this window's height, width, and all can be changed in its type. But the window's sill height is given over here, right? So if all the others are written over here or can be changed over here, just why only one parameter that is accessible only here in the properties bar? That is because this parameter, the sill height, is designed as an instance parameter, whereas the others are programmed or made as the type parameters. So the main difference is, if you think whenever the object or element is going to be placed, it needs a modification or it is going to change from object to object. Say, for example, I've just placed a window over here. And if I want to place one more window, I'll just take window. I'll just place the same window again. But here, for this window, I'm going to give sill height as 191200, say. And for this window, it may be means both the windows are same height and same type, but its sill height are different. So that means whenever the family is there and each and every instance of that family is going to vary with dimensions or with input data, then we are going to classify that type of data as instance data, and we are going to place it as an input in the instance parameter. But if you think that parameter is not going to change its shape, then you are going to put it in type parameter, which means you are going to change, if at all it's going to change, it is going to be changed for all the blocks or all the families. So for example, if I change the input in the type parameter, what happens is, let's see over here, the height is 610, right? If I change it to 700, it's going to be changed for all the blocks. But here in the instance parameter, if I change it to 1300 or 1400, say, going to change only for individual element. So you understand my point, right? So if it is an instance parameter, what happens is the change we are going to do for the family, it's going to be for that particular family only. But if you are putting some parameter in the type parameter, it means that the change we are going to do is going to be affected by the family wherever it is present. This point 0460 and 0 into 0610 mm, wherever this is there in the whole project, that is going to change. But if it is of a type parameter, sorry, instance parameter, wherever we are going to change, that will be restricted only for that element. So that is the main difference between type and instance parameter. So you can imagine what are the use cases for instance parameters. This is not much. So for example, if I take this door, there are not many instance parameters, only one or two given. But if you go to type parameters, there will be many type parameters, which means these are things that not we are going to change far often, but whatever we are going to put in instance parameter, it indicates that we are going to change them according to that element, according to that given situation. Clear? Any doubts in this one?
No, sir. No.
Okay, you're clear, right? What is parametric family?
Yeah.
If you try to explore, there will be a lot of doubts and there will be a lot of confusions as well. That I can assure. But as you practice, things will be clear. There will be a lot of this parametric constraints and all the things. So there will be a separate set of people in offices who only do the families. Because as I've said, the Revit adoption has picked up in India right now. So the companies which manufacture or produce doors and windows and especially these mechanical parts like fittings, pipe fittings and all, they are acquiring people to only do the families because that is going to be useful for them. They'll directly upload these families in their websites so that if any construction company is going to ask them, they can just straight away take them from their websites. This is true for doors, windows, and many pipe fittings, and as well as say if you're using Tata products, you might have known they are producing or they are making sure that all these families or AutoCAD drawings are available in their websites so that the customers can use straight away. So that is what parametric families are. Now let's see what massing is. So we do create parametric families when regular families are not sufficient. The same way, if geometry of the object is very weird. So for example, if you want to create a tilted wall, you can create multiple types of walls over here. But there is no possibility of you to create a wall with a tilt, say 20-degree or 30-degree angle. All right, with all these tools, it is not possible. For such instances, we are going to mass. So where do we find mass? Here in the massing and the side. Here also we have two types of masses, in place mass, and also we can create new mass. That is conceptual mass. So depending on your requirement, you can create either mass here or in place mass. Both the options will be same. Let's see what they are. I just go to massing in place. So for in place mass, you have to name it. After naming, so whatever I'll just show it for a tilted wall first. So whatever your wall dimension is, the 300 mm by say your wall is of 5000 mm. And then you have to go to any elevation first. So going to elevation, you have your mass first. Okay. That if it's not visible, you can just go to 3D also. Click on this. You have something called create form. Select solid form. Now we have our height as well. Just go to any elevation where it is visible. Okay, now it's visible. So just give your height. If you're okay with this height, after that, you can just select any side. This is going to tilt. As per your design, just tilt it wherever you want. So it will look like this. Something like this. Then finish the mass. So we have a mass. This is just a sketch or a mass. It's not going to have any value. In order to create a wall with this mass, you have to go for architecture wall. So we have seen all this, but we didn't see anything, this thing, right? Just select wall by face. Wherever the wall is, the face of that wall is, you can just select that particular face. You have your wall. Since here I did not check the 300 mm, select everything. Now filter, just select only mask. So here we have, sorry, not mask wall. Here, this is not 300 mm wall, 200 mm wall. So it's not going to fit. As soon as I select 300 mm wall, it's going to fit exactly. So you can just go to any elevation, it's going to fit exactly as per the dimension. So as soon as you have your wall, there is no need for the mask. Select everything, go to filter, uncheck the wall, only mask will be there. The mask can be now deleted. We have a wall. Component of Revit. It is a wall. If it is a wall, you know its volume, its area. This mask, now if you want to create with the regular tools, it's not possible, but we have done it with the mask. Let's take one more example. I'll just go to level 1. You got the view, right? Why we use masks. The same way, I'm going to create a complex structure. I'll just go to masking and site again. Go for in place mask. Take any random shape like this. And now, solid form. So I'll just go to new elevation. This like this. You can just hand it, or you can just create like this, which I'm trying to do. Just move any particular point in X and Y and Z direction like this. So this is a weird geometry, right? And I want to create a glass wall in all the directions except base. Right? This is my requirement for this geometry. I can just select any tab or delete that particular tab, or sorry, not deleting. We cannot, because this is a shape. If you want to create a glass structure in 3 dimensions, in 3 sides, or in 4 sides, and one side you want to have a floor or a roof, you have to first finish once. Then we have a structure like this over here. This is just a mask. It doesn't have any material. In order to apply material, you can just go for this architecture. Here we have something called curtain systems, or you can go to masking, select create curtain systems over here. Both are same. So wherever you want your system, that is curtain system. So this is your auditorium or something that of that kind, and you want all the sides to be of glass. Only one side left, that is this side. So we have all the sides with the curtain system. Then you can go for create system. We have a curtain systems with the glass. Not only that, now we have to create mullions for this. For creation of mullions, we have to go for mullions, all grid lines. Now select the whole system. See, we have started with nothing, but we have grids in all the directions now. If you have grids and if you have glass, this can be sent to the fabrication team. They can prepare the fabrication and they can assemble this structure in real time, right? If you want to create something in real time without this masking function, it's highly impossible. Now the only thing remaining is under part, that is our flow. I'll just go to roof. This under part is there, right? So we have there, but this part, this part. But now, after you're done with your modeling, I'll just go to EG first. Annotation categories, levels, I'll turn it off. Since they are hindrance to now, I'll just select everything, filter, select, uncheck mask, delete the mask. After you're working, you have your structure. The structure is finalized. You don't have any use with the mask. You can just go to any elevation, and that structure is going to look in this particular elevation like this. Now you can edit or whatever you want to do, you can do. Like say if you want to draw floor, just floor architecture. Even the shape is complex, and just try to draw flow like this. You have a base also for this. You can just build a wall or whatever your design is. You can straight away start working like this on it. So this is a 3-dimensional mask. And if you want to edit this system, same as we've discussed in the first class, you can give whatever the data you have, the angle or say glass type, you can change it. So you can see this mullions and all the glasses all are changeable. These things are changeable here, and even in the materials also you can just select the system type of system you are using, layout, and how many millions you want. That can also be changed in the grids here, the borders here, that can also be changed. And if you want to change the customized curtain system, you can create your own curtain system and you can give that one also. Likewise, we are going to create a unique shape or object. This is also true for curvatures and all. As the conceptual process increases, the complexity also increases. So you can use many options. I'll just so if you go here, these are our basic lines. In spite of our main, there are multiple functions you can create apart from basic lines. Like you can create something called point elements, which means these points you can create or modify individual points and take a shape along those points to create paths. These paths then you can create or divide, and based on this path you can again create a form. So after you're done with your shaping, just go for solid form. Then you have your shape. Based on that shape, again you can just create whatever the design you want. So this is an advanced version of the modeling, mostly used for conceptual designs and highly conceptual buildings, not for a regular use. Okay.
Sir, we won't be able to show any wall thickness there for massing.
Wall thickness. Sorry.
Yeah, in the sense like a wall, can we do a massing?
You can provide the shape for the massing, but wall can only be drawn over here with this tool only.
Okay. Okay.
I'll just show. Just shown just now. I'll just show anyway once again. Go to in place mask. So why do we use this in place mask? We do use because there are certain things which we cannot do with the regular elements. Let's say I am going to create 200 mm wall. I'll just go to any elevation. This elevation is not going to be visible. Or let's say we are going to 3D. So here, first let's make it a shape. Now we have, maybe we can see 3D. So here, imagine this as one particular dimension, and you have a tilt over here. Here, your wall is like this. Okay, I'm just going to pick this particular thing, change it like this. Now, this is a wall. Your requirement is, this is what your requirement is. Your wall is looking like this. For that, we are taking a shape with the massing. After you finish your massing, this is just a sketch. Imagine this massing as a sketch. It has no value, nothing. You have to create the wall actually by going to wall by face. Here, whatever your wall thickness is, you have to select any face, external face or internal face. As per the face, the wall is going to sit exactly in flush with your design. After creating your wall, then you have to select everything, go to filter, remove the wall, only mask will be there. The mask will be then later deleted. So the use of mask is then completed. Now, whatever we are left with is only our wall. This, the dimension you asked, right? This is what the width. This you can control, right? Because we are taking 200 mm wall. If you change it to 225 mm wall, it's going to change. If you try to make it as 300 mm wall, it is going to change. We are taking the shape because only the angle or tilted wall is not possible with our regular tools. That is why we are giving the shape. Okay.
Okay, sir.
Now the last concept for today is something called topo surface. For example, if I want to make the trees and all, that is as I just show in the so this is what topo surface is, right? So you have your plantation, you have your roads, you have your height of that particular. If you want to show this, that is called topo surface. Let's see how it's done. Whatever we have done until now, we have done in the floor plans, ceiling plans, right? Now, after the floor plan, there is something called site plan. So if you want to create something in the site, you have to go for site plan only. Here in the site plan, as soon as I go to site plan, you can see the project base point. Just remember, we are not going to do this, but whenever you set a project in Revit, after opening the project, the first thing the BIM manager or the project coordinator is going to set the project base point. This is the first step they are going to do, because without this project base point, whatever we do in Revit is waste. Where the project is according to north, south and east, west coordinates, and what is the elevation of this project. This we will get from the surveyors and all this data will be fed. And there are two elements over here. One is project base point, the other one is survey point. You can see these two, you have to make sure that they are aligned properly. And once they are aligned, you can just make sure that they are aligned properly. Then only the construction or the BIM company or the BIM manager are going to start the project. After this, they are going to go to manage, and in the manage, they have something called project information. They are going to give the details of where the project is and what is the organization and what is the status and all the things that is related to the project. They load that. But the important thing is you have to have the full version. The license should be full version. After that, they will go for the parametric, not parametric services. They'll go for this. All the parameters that they are going to use, they will define the parameters such as length, width and height. Everything that is related to this project will be set over here. Then they'll go for location. For this also, you have to have the full version. They will give where the project is there in the map. So therein, it's going to be attached with the GPS coordinates. Here you can see the coordinates will directly then be attached. The position will also be attached. So there are two norths, project north and true north. So in Revit, normally this is the project north. If you want to align your project north to your true north, there is an option. So you can rotate your project north here to your true north. So if I go to level plan, as in every drawing, this is your north, right? This is your north. That north is called as project north, but that may not be your so what you call true north or the north as per the site. If you want to adjust, you can adjust here with this position alignment. So the first thing we are going to do is we are going to give the project base points. Then you are going to go give the project information. Then you have to load the location of your project. So these things are mandatory when we are setting the project, not every time. And this is not done by everyone. Okay. After that, now we are going to site again. We are anywhere in the site. I will just go for a single site. We have an option called topo surface. Here, whatever the point we are going to give, that we can directly feed into the software. Why? How? Instead of place a point, you can just go create from import, select import instance. If you are specify point, this project data will be in the form of CSV file format. So if you're from civil background, I think you might have known what CSV is. So this topo surface data will be in the CSV file format. If you have this topo surface data collected from your surveyor, you can directly import, and the topo surface that I have shown already, right? This will be automatically generated in the Revit. But if you don't want that and you want to do this process manually, it's a time consuming process, but you can do it. For that, I'll just go for place point first. Then you have to choose your elevation. Let's say my elevation is I'll just start with minus 4,000. I'll give something like this. The elevation starts building. Now I'll just place a point again. Minus 3,000. I'm just showing for the reference purpose only. This may not look actually as per the site condition like this. Then I'll just go for I'll go for something like this. Then I'll go for 0. 0 is our like 0 level of our project. So if you are having any altitude, then you can also place 100 or just say 200. You can place your 200 like this. Then you can finish it off. And as soon as I go to 3D, you can see I have created a topo surface. This can give the material. By going to material, if your material is earth, you can just give the earth material. It will look in the form of earth. If your grass, just change it to grass. So there is no grass. So first, let's download the image of grass. Okay, this looks fine for me. This looks fine for me. Make it easy. So materials. Click on the material. As I've said, you can create material here also. Create new material. This is, I'll rename it as grass. So grass, appearance, load the image. So it's okay. Apply. Okay. Now the grass will be applied. If I zoom in, you can see it's going to look like grass, but it's patchy because I did not do a proper work. If you render properly, you can give it an exact result. But if you want to give two materials to the same surface, just go to site, click this site, you can go for edit surface, and wherever you want to place a point again, or you want to give some additional data, you can just split surface. Select this and just split it like this. This area, it will have another material. If you want to give another material, you can just give. Here, let's say I want to make it as earth material, because anyway I am going to clear this area. So you can see it's going to look like earth. So in this area, I can just build my project. For that, I can just go for building pad. So which means I'm going to evacuate if it is more than 0 or the height is more than 0, it's going to evacuate that area. Be in this layer only. Let's say I'm here. You can see as soon as I create, there is a leveling. That leveling is going to take place, and wherever the height is material is to be removed, the material is removed. Wherever the material should be added, that is added, because I am going to create the building pad. The pad is also modifiable. You can see its structure, width, depth, everything can be changed. I've created this pad because this pad helps me to create the structure in uneven surfaces. So as soon as I go to level, this pad will be there, and I can locate this pad with the reference plane, something like this, something like this. And as soon as I go to level, the reference plane is visible. Now I know where my building pad is. If I draw any wall like this, I'll just show, I'll draw a wall like this. And if I go to 3D, you can see it's going to sit exactly on top of my building pad. Right? It's not going to affect my project plan in any way, because only in site only you can see all these elements. If I go to floor plan, these things are not going to be visible, so that they are not hindrance to my project. Okay. Likewise, in the site plan, I can place trees and all the elements. Just go to massing and site. If you want to place a tree, go to site component. There'll be certain site components readily available like this. These are the trees. We can place any tree like this. And if I go to 3D, these are the without rendering output. If you render, it will be somewhat better. So these are the trees. Likewise, you can give the parking components, and if you have signal lights or something like that, if you want to place vehicles, cars, these things can be accessed in the insert load family. If you go to this parking components, you have the things for parking elements, like the curves and all. Like if you go to site elements, you can see road markings and also post boxes, drainages, pins, accessories, bollards, such as such. And also if you go for trees and all, they can also be found in this families. Put them and prepare your project like this. So this is what your site components in the massing inside. So there are certain elements like grading and all. I think we don't have to go that depth in our current Revit requirement. I think these are the sufficient tools for us. I think with this, I'll just conclude today's session. Stop recording.